Day 3, we're going to start out with some angles. We have vocab as usual. An angle is the space between two rays that share a common endpoint. The sides of an angle are the rays that form the angle. Our vertex is the common endpoint of the rays. An acute angle measures less than 90. A right angle measures exactly 90 degrees. Obtuse measures more than 90. Straight angle measures exactly 180, and congruent angles have the same measure. An angle bisector is a ray that divides an angle into two angles of the same measure. So let's go back up here to the top. If I draw us out an angle here, then I'm going to highlight these as we go. The angle would be the whole thing. The sides of the angle would be these rays right here. And our vertex would be this dot down here at the end where the two rays meet. Be careful with your acute and obtuse. Remember that less than 90 does not include 90, and that greater than 90 also does not include 90. So don't try to get cute with it and say 90 or above, less than 90, more than 90. A few different ways that we can name angles. Don't worry about this Quizlet link here. That's an old link. I have the new link in our Unit 1 module for the Quizlet. So the angle can be named angle ABC, angle CBA. You'll notice that in both of those, your vertex angle is in the middle, angle B or angle 1. If we're going to name all of the angles in this little diagram here, we have 1, 2, 3 different sets of angles. So if we start up with the top, we have angle AOB. You'll notice that I put a little mark through my angle signs. That's just because that's how I learned to write them when I was your age, and that way it doesn't look like a less than symbol. So I have angle AOB. The bottom, I have angle BOC, and then the entire thing I can name angle AOC. One thing that I cannot do is label it angle O, because there are 3 angles there with a vertex of O. So our angle addition postulate, much like our segment addition yesterday, our angle addition tells us that if B is in the center of angle AOC, like this diagram up at the top, then the measure, it's a little m, of angle AOB plus the measure of angle BOC is equal to the measure of the whole thing, angle AOC. And if angle AOC is a straight angle, then we know one other thing that we can add, and that we can change this to 180 degrees. So the measure of angle AOB plus the measure of angle BOC is equal to 180. So let's take a little adventure into what we did yesterday. Remember how if we had a segment, we had segment AB is congruent to segment BC. The minute that we took those bars away, we also took the squiggle away from our congruent sign. This way they represented numbers. In the same way it works for angles. So if we have angle A is congruent to angle B, then we would say the measure of angle A is equal to the measure of angle B. The reason that we do that is because with these values here, we can add, subtract, multiply, and divide just like normal numbers. We can put them into number sentences. So if we go ahead and list these out, the measure of angle RST is 50. And the measure of angle RSW, so that's this whole thing, is 125. What is this one? So if we do 125 minus 50, that will give us a value of 75 degrees. So I'm going to erase that so we can do that example again with some different numbers. If the measure of angle RST is 45 degrees and RSW is 110, then the measure of TSW would then be 65 degrees. All of this is 110. All right, if GEF has a measure of 90 minus x and DEG is equal to 6x, it wants us to first find the value of x and then find the measure of angle DEG. So one thing that we do know is that angle DEF, so the measure of angle DEF, is a straight angle. It will be 180 degrees, so I can add those two together. 6x plus 90 minus x is equal to 180. So I have 5x equals 90, and x is equal to 18. Now if we take 18 and plug it back in, if I do 6 times 18, that gives me a value of 108 degrees. On these, I would encourage you to draw some pictures. So given angle AOC with point P in its interior, so I'm going to stop there. Here is AOC with point P in its interior. I'm going to make that not smack dab in the middle. The measure AOP is 3x minus 1. The measure of AOC, so all of this, is 9x minus 3. And the measure of COP is 5x plus 5. It wants us to find the value of x and then find all available angle measures. So we're going to add the two smaller to be equal to the larger. 3x minus 1 plus 5x plus 5 is going to be equal to 9x minus 3. Combine the left side. 8x plus 4 is equal to 9x minus 3. Let's see, add the 3. So x is equal to 7. And then if we plug the 7 back in, 3 times 7 is 21 minus 1 is 20. This will be 35 plus 5 is 40. And just to double check our math, 9 times 7 is 63 minus 3 is 60. So those numbers all add up. The last one, given angle AOC with point M in its interior, it gives all of those and says towards the end that M lies on the angle bisector. So whenever we draw this one, let me get all this listed in here. Here is A, O, and C. And it tells us that M lies on the angle bisector. So I'm going to mark these two angles congruent. Here's angle M. Tells me that the measure of angle AOM is 7x minus 5. And MOC is 4x plus 10. Find all available angle measures. Well, if our angles have the same value, they are congruent and they are therefore equal. So 7x minus 5 is going to be equivalent to 4x plus 10. Subtract the 4 and add the 5. So x is equal to 5. And if we plug those in, we should end up with the same value for both of those angles. So 7 times 5 is 35 minus 5 gives me 30 degrees here. And 4 times 5 is 20. 20 plus 10 is also 30 degrees.